Hi, it's Carly McAvoy. This is part 3 of the 97 practice final. There's going to be 4 problems in this video, and you can see them on the screen right there. First one is a rectangle is 3 less than twice as long as it is wide. Wow. So let's talk about what that looks like. We have a rectangle. We have some width we don't know, and the length is 3 less than twice that. So twice that would be 2w minus 3, 2w minus 3. Now if we were talking about perimeter, we would add all those sides up, but we're talking about area. So what I know is that w times 2w minus 3 equals 35. And so then we're going to solve that to find out what w is, and once we find out w, we can find out what L is by plugging into this expression. So we're going to have to distribute, get 2w squared minus 3w, and we're going to bring that 35 to the other side by subtracting 35 from both sides. You can see that 35 minus 35 would go away. Now I'm hoping that I can factor this into something that is nice. You can use the box method. I can see 2w is going to be 2w, and 2w squared is 2w and w. But if you don't see it, you can always use the box method to help you out on any of these kind of problems. I have 2w squared, which I just said was 2w times w, because there's really no other way to do that. And then I have minus 35 up here, and I have negative 3w down below. So what I want to do is use 35. I want to use 5 and 7. But I want to use 5 and 7 in a way that could possibly get me to something that works. And so I'm going to say put the 5 up here and the 7 here. So I've been doing this for a while. I can usually see what it's going to be. You might have to guess and check a little. Going to check that by going straight across. 2 times 5 is 10w, and 7 times w is 7w, and you want this to add up to negative 3. So the larger, greater number here has to be negative. And that means we need a negative in this row, and we never put a negative in the first column, so it has to go here. 2w times negative 5 is negative 10w. W times 7 is 7w, and if you add those up, you get negative 3w. And so what we have is w minus 5 and 2w plus 7. Now I can set both of these equal to 0 to try to solve, but look what happens when I try to solve this one. I get negative 7, and I have 2w is negative 7, and if I divide by 2, you see how I'm getting negative 7/2? We're talking about the length of a rectangle. It can't be negative. So this solution is extraneous. It works for this equation, but it doesn't work for our particular problem. We can throw it out. We also have w minus 5 equals 0. If we add 5 to both sides, then we get w equals 5, and that's the only one that works. So our width equals 5 meters. And our length, well, that's 2 times 5 minus 3, because we said it was going to be twice as long, but 3 less than that. So 2 times 5 is 10, minus 3 is 7, so we know that we have 5 meters by 7 meters for our rectangle. In the second expression, we're talking about, oops, I left out the word right triangle. Well, just trust me on that, but I meant to say right triangle, and yours on the test, if it was a right triangle, would say it. It says the shortest leg is 3 feet shorter than the other leg. So let's say that this is the long leg here. We're going to call it x, and 3 feet shorter than that is x minus 3. And the hypotenuse is 15. What are the lengths of the two legs? So we know from the Pythagorean theorem that a squared plus b squared equals c squared. A squared, let's say, is x squared. B squared is x minus 3 squared. And c squared is 15 squared. So there's a lot to do to solve this problem, so let's get at it. We're going to have to multiply this out. X minus 3 times x minus 3 is x squared minus 3x plus 9. That's using the FOIL method, which gives me x squared minus 6x plus 9. Yikes. And I already had this, so I have x squared that comes from here, and then I have plus x squared minus 6x plus 9, And then I have 15 squared, which is 225. And I'm still not really close to solving this, but I'm moving in on it. X squared and x squared is 2x squared minus 6x, and I'm going to subtract 225 from both sides. So we're going to have 9 minus 225. And just so I don't make any mistakes, I'm doing that on my calculator. That gives me negative 216 equals 0. Do you see how this equation has a 2 in every term? Wouldn't it be nice if we could just divide the 2 out? Well, we can because we have an equal sign there. So we're going to divide everything by 2 and give ourselves something a little easier to work with. X squared minus 3x. 216 divided by 2 is 108 equals 0. That's great because that makes it much easier. What we want to do is factor this expression so that we have 2 factors there. I can see that x squared is going to be x times x. Remember to use your box method if you need to. We're going to say that 108 is 9 times 12. That's good because there are 3 apart and they multiply that. We want more negatives, so that the 12 should be negative and the 9 should be positive, because 9 times positive 9 times negative 12 is negative 108. Again, use the box method if you need to. Easy for me to say. And then I'm going to set each of these equal to 0. When I subtract, I get negative 9. You can't have a negative length of a side, so that's a solution that doesn't make sense for our problem. And then if I add 12 to both sides, I get 12. Now what is 12? Well, 12 is the longer leg. X equals 12. So x minus 3 equals 9. So the legs are 9 and 12 feet. All right, that's the hardest one, I think, for solving that in the application. But Pythagorean theorem is so nice to know. Now we're going to solve this. This is to the second power. And if we have a radical equation like this, something to the second power, excuse me, we can take the square root of both sides to solve it. Just like you can add 2 to both sides or divide both sides by 2, you can take the square root of both sides. And so I'm going to do that. I'm going to have the square root of n plus 8 squared equals the square root of 64. Now you see how this is to the second power? I want 2 solutions because I have something to the second power. So how I'm going to get those 2 solutions is the second power, 2 goes into 2 one time, which leaves n plus 8. And then instead of just saying the square root of 64 is 8, I'm going to say it's positive or negative 8, which is true. Negative 8 times negative 8 is positive 64. And so I have 2 possible things going on here. N plus 8 equals 8, or n plus 8 equals negative 8. If I subtract 8 from both sides, I get n equals 0. And over here, if I subtract 8 from both sides, I get n equals negative 16. Do both of those work? Well, if I come back up here and say n is 0, that just makes that go away. 8 squared is 64. That would be awesome. If I say it's negative 16 plus 8 is negative 8. Negative 8 squared is also 64. So these are both solutions. Makes sense that I had 2 solutions because I had something to the second power to start with. And this one's sort of randomly different than everything else we've been doing, but we're coming up on more of that. In this case, it asks you to simplify, which means you want to rewrite these expressions in factored form and then cancel what you can. I'm going to go ahead and do the bottom because I can just see here they have a common factor of 3 and also of x. If I divide 3x squared by 3x, what do I have left? Well, I just have the x, and if I divide 9x by 3x, I would have the 3. You can always distribute back to get what you started with. And then up here, I'm going to say use the box method if you need it, but you might be able to see 3 times 4 is 12 and 3 plus 4 is 7. So it looks like plus 3 and plus 4 because everything in there is pluses. Now that you've factored everything, cancel what you have in common, and you would be left with x plus 4 over 3x. That is the simplified version of that. All right, we'll be back for part 4 in the next video.